Hello friends, let us see D'Alembert's ratio test and an example of it. So the D'Alembert's ratio test, the statement is given by let summation un be a series of positive terms and let limit as n tends to infinity of un plus 1 upon un equal to L. Then if L is less than 1, the series summation un will be convergent, and if L is greater than 1, the series summation un will be divergent. And the test fails if L equal to 1. That means for L equal to 1, we cannot say the nature of the series. We have to go for any other method. So thus we can say whenever we find the limit as n tends to infinity of un plus 1 upon un, whatever the value you get, check it. If it is less than 1, the series is said to be convergent. If the limit value is greater than 1, then the series is said to be a divergent series. If L is equal to 1, we have to go for any other method. Okay, now let us consider an example based on this D'Alembert's ratio test. Test the convergence of summation n equal to 1 to infinity n factorial 3 raised to n divided by n raised to n. So here un is directly given, nth term is directly given here. We'll write it as the nth term un, n factorial 3 power n divided by n raised to n. Now we'll write what is un plus 1. Just replace n by n plus 1 here. So it gives you n plus 1 factorial 3 power n plus 1 divided by n plus 1. Again power is also replaced by n plus 1. Now un plus 1 upon un, it is n plus 1 factorial 3 raised to n plus 1 divided by n plus 1 raised to n plus 1. Now we'll write the reciprocal of un and multiply here. Into we have n raised to n in the numerator, n factorial upon 3 raised to n. Now we want to cancel the terms. For that we'll simplify this. N plus 1 factorial will be written as n plus 1 into n factorial. Similarly 3 raised to n plus 1 will split it as 3 raised to n into 3 raised to 1. Now denominator again n plus 1 raised to n plus 1 is there. We'll split it n plus 1 raised to 1 as one term, n plus 1 raised to n. Now your un term, this is kept as it is, n power n factorial 3 power n. So now look at the terms which cancels. N factorial cancels, n plus 1 cancels, and even 3 power n cancels. Now what remains is 3 into n raised to n divided by n plus 1 raised to n. Now 3, and here we'll take n common in the denominator. In the denominator term, take n common. It is n raised to n. 1 plus 1 by n raised to n will get. So this is remaining, that is un plus 1 upon un. Now we'll go for limit as n tends to infinity of un plus 1 upon un. It is limit as n tends to infinity of the term 3 divided by 1 plus 1 by n raised to n. Now we know that this is a standard limit. Limit as n tends to infinity of 1 plus 1 by n raised to n, it is e. So we get the value as 3 by e, and e is less than 3. We know it. Hence 3 divided by e becomes greater than 1. Now by D'Alembert's ratio test, our L is greater than 1. That implies the given series is a divergent series. Summation un, it is divergent.